Now that we're in Unit 2 of Castle, learning some things about electricity, we've now been introduced to a capacitor. And we're going to take a further look into ways that scientists use to communicate things about electricity. Just like sports that might have languages that are specific to, say, calling a play in football or basketball or volleyball or describing a set in swimming, or if you're a YouTuber or a gamer, you might have certain ways to describe actions or the way you would play the game. The electricity stuff we've been studying has chosen a few ways to communicate what we're talking about. Over the last few weeks, you've become familiar with this. We've got a 1, 2, 3 cell battery pack with 1, 2, 3 round bulbs in a loop, and you would assume that these bulbs would light. You have already adjusted your brain to understand that that picture really represents something real. And the thing that is real is the 3 cell battery pack. And we even have the red springs up here, the blue bolt, and we have our 4 wires and 3 bulbs that are lit here. Well, there are other ways that we can communicate this as well. After you've taken a look at Unit 2, reading number 1, it introduces the idea of schematic diagrams and the idea that simple drawings that we've been using can be drawn up in a unique way that would make more sense to, say, electrical engineers or architects or somebody building a machine or building a building. So let's take a closer look at what these symbols look like. Taking a look at your sheet, we've got a basic battery or cell is represented by a long line and a short line. The thickness of the lines don't really matter, but the longer line is the positive terminal, the shorter line is the negative. So if you had, instead of having a 1 cell battery pack, you had a 3 cell battery pack all connected together, you've got a long line, a short line, a long line, a short line, a long line, a short line, and with the positive end this way, negative end this way. Down here we've got bulbs, round bulb that is not lit. In the version you can see, this is all glowing yellow, so this is a round bulb and it is lit. You know that there are long bulbs in your kits already, but we haven't used them yet. I notice over here the L is missing from the printout that I made. And notice the difference between a round bulb that is lit, has bulb rays, versus a bulb that's not lit. A long bulb that is not lit, a long bulb with bulb rays. So this long bulb is lit. And then as we move towards the bottom, a capacitor, which we saw earlier today. It has 2 parallel lines of equal length, and then the compass that we have drawn in the system looks like this. So what about this loop we were taking a look at before? Well, this is much quicker and easier if you're drawing pictures. So I'm going to bring you in nice and tight and close on this now. So how would we go about drawing this? Well, we said a long line and a short line that are parallel to one another represent 1 cell. Here is our positive terminal, here's our negative. But this has a 3 cell battery pack. So now we add a second cell, the long line, the positive terminal, short line, the negative terminal, and a third long line and short line. So if we look at the battery pack overall, the longer line is on the positive terminal, the red springs, negative terminal over here. When we draw schematics, they should be very, very neat, and all the corners should be rectangular or square in shape. We want to center the wire we draw off the battery pack, and again, squared lines is what we're looking for here. And now we're going to draw our first round bulb. Take it across, square off an edge, our second round bulb, a third round bulb, and then I'm going to pull a wire straight off the bottom of the battery pack and then this way to make sure that we have a good square over here. Now because these are round bulbs, we need to put R's in here. And would these bulbs light? Is this a closed loop? Of course the answer is yes. So we'll add bulb rays to our round bulbs. Now, recently we saw a capacitor with 2 bulbs in a loop. When we hooked up this the first time, the bulbs were unlit. but after charging the capacitor, then the bulb's lit the second time. Let's say this is an uncharged capacitor. We'll say this is a discharging capacitor. We'll say that the capacitor has already been charged. So this is a discharging loop. So we have a closed loop, and we'll draw this as a discharging loop. We'll go ahead and put the capacitor here. We need two parallel lines of equal length, unlike the battery, which had a long and a short line. I'm going to center the wire off of the capacitor, round bulb number 1, round number 2, square it off again. We've got a round bulb and a round bulb, and if this is a discharging loop, these bulbs would be lit. And of course, each of these straight lines along here represents each of these 3 wires, and then 2 round bulbs and sockets. The last one would have been circuit B from activity 1, in which case we need a 3-cell battery pack, 2 bulbs, and then a capacitor. So our 3-cell battery pack, we have 1 cell, 2 cell, 3 cell, center a wire off the positive terminal. We're going to have 2 bulbs, round bulb 1, round bulb 2, that was not centered very well. Now if I want to put the capacitor down here, I always want them at a 90-degree angle compared to the wires, or perpendicular to the wires. So our two horizontal lines here, I'm going to draw them as parallel down here because they want to be perpendicular to whatever wire they're on. And so once again we have round bulb, and this of course is a charging loop. And these bulbs would be lit. The temporary lighting of bulbs with a battery pack and a capacitor, charging loop. So there is a basic introduction to schematics.